Dr. Babasaheb Ambedkar Open University.
Hello student, I Dhiral Pargi, Assistant Professor in Dr. Babasaheb Ambedkar Open University, welcomes you in the class of Data Structure and Arrays. Today we are going to learn our first unit, that is Data Structure and Array. Before starting for our subject Data Structure, let's just understand why we want to learn data structures as a subject, right? As a computer and IT student, we all are aware that to go into the digital world, we need to understand each and every programming concept very depthly. But when we are going in a real world or in a company scenario, we all have one mindset that each and every of us has to understand about the programming languages. But when we are trying to learn programming language and going to work in a real world scenario of company, we will face different kind of issues regarding code development. At that point of time, we have to understand about each and every concept of data structure. Suppose when we are going to any grocery store, or we are going to purchase any clothes in our market, right? So if at that point of time everything in that grocery store or in a market is collected in a one form or not sorted everywhere, so at that point of time we might have different kind of concept, like if it was sorted, then we can find our things very easily. So in similar way, in our computer programming languages, our machine computer store different kind of data. If the data is not sorted or stored in a particular way, so at that point of time we might face that if it is sorted, then we can fetch our data particular in very fast or in a easy manner. So to do these things, we require a data structure as an subject, right? For example, when we are going to any lunch or dinner in a buffet, at that point of time every plates are put in the stack format. So when we going to take a plates, we will fetch one plate and next person will fetch another plate. At similar way, in our data structure, there are different kind of format and data structure available for our computer, so that we can easily use and retrieve our data. So for this purpose, it is very important to understand the concept of data structure. Today we are going to learn about learning objectives of this chapter, plus next we will go for data, information and knowledge. Then we will understand what is data structure. Then we will classify the data structure and see time and space complexity of algorithms. So for data structure, we must understand the definition of data, information and knowledge, because before going for any kind of storage related collection or information about structure, we must know what is data, what is information, what is knowledge. Then we will going to understand the concept and need of data structures, understand the concept of primitive and non-primitive data structures, and next we will going to understand the time and space complexity of algorithm. Now let's just start with what is data. Data is a raw piece of part. When data is processed as per the requirement of the user, it becomes information. A collection of information in an organization manner which is stored and available to use as per requirement is known as knowledge. Data is the very first level of abstraction, followed by information being the next and the knowledge being the final and highest level. Before going to our technical language, let's just understand with the example, right? Suppose we have a data in university, we have data of different courses like computer science, information technology, electronics and data processing, all, right? So this students data regarding this all the subjects are stored in universities different areas, right? So we can say this data is in a row piece. When we collect all the data to show you a result at that point of time, it is says that it is an information. From result portfolio, you can fetch out your data, that is called an information. So when data is collected to create a part, so that it is called as an information. After that information is stored, when we want to compare our result with other student, like I am from the computer department and I have scored 85% and there is another student who has scored 80%. While comparing, I can say that I have 5% more result than that student. So I got the knowledge that from their data that I have scored 5% more than particular student. So when the data was in the university scenario in different department, that was data. When it is collected and stored into our result section and it will show you on your result time, so it is called an information. And while I am comparing that result with another students and getting knowledge of it, that this is what I have get from this data, is called knowledge. So data is the very first level of abstraction, followed by information being the next and knowledge being the final and highest level. When we are saying that data is a first level, it is in a raw format. When it goes a higher level of abstraction, that it becomes information, and when we find any kind of knowledgeable information from that, so it's called as an knowledge. Now let's moving to our data structure. Data structure is a way of storing and retrieving the data into computer memory efficiently. As I have told you, when you want to store any kind of information regarding any of the things, whether it is in your real life like your clothes, your plates or your data, when we store it in a short format, then we can easily retrieve it. So data structure is basically provide a way of storing and retrieving the data into computer memory efficiently. In simple word, it is an organization of data into computer memory. We are storing our data in a particular format so that we can easily retrieve, access or do manipulation on particular data using it. So data structures provide the way to manage data efficiently as per our requirement. Different data structures are designed for data arrangement to meet a specific purpose. This arrangement helps to access data efficiently with minimum efforts. Let's understand it with our layman language. For example, when we went to store or put our clothes, we put it in a stack format, right? And when we are having a books, we can put it in a vertical format also and in the horizontal format also as per our requirement. When we want to utilize our resources maximum, so based on our requirement, we change our way of storing the contents to easily access and modify particular things. So for this purpose, when we want to use data structure as in our computer machine, we will have different kind of formats in which we can store it in different manner so that we can find efficient use of our memory and resources. So moving to our next point, that is classification of data structure. Data structure basically classified into two main forms, that is primitive data structure and one is non-primitive data structure. Primitive data structure are basically understandable by machine language. When we say it is understood by machine language, so we can say that it is different and individual as per the machine. If we have 32-bit processor, then we have different kind of storage for it. If we have 64-bit processor, we can have different kind of storage for it. So as per this, primitive data are understandable and basic that are used by machine. Next is non-primitive data structure. Non-primitive data structure are the way of derived from primitive data structure. They are not basic data structure and not directly understandable by machine. When we want to store or use the non-primitive data structure, we can say that we will use this primitive data structures in our non-primitive format to easily use more data and fetch it effectively. Now, in primitive data structure, we have integer, float, pointer, character. In non-primitive data structure, it further divides into array, list and file. In list, we have two kind of list, that is linear and non-linear. In linear format, we have stack and queue. In non-linear format, we have graph and tree. Now, let's just start understanding each and every classification of data structure in deep. Now, first we will go for primitive data structure. Primitive data structure are basic structure and are directly operated by machine instruction. As I have told you, it is directly operated by machine instruction. They have different representation on different computers. We have different computers like Windows, Linux. If we have 32-bit format, then we will use data regarding 32-bit format of that. That language itself has all the built-in context to store that data. Like integer, float, character, pointer. As you all have learned somewhere, all these data types in your C language also. Integer store a whole number that doesn't contain any kind of floating point or a pointer digit. Float contains a number which have floating point, or we can say a decimal digit provided by it. Then a character that store character or string data, character data of individual type. Using character, we can use it as a string also. You will see it in our next lectures also. In pointers, we have a memory allocation for particular address. You are going to learn it into a C language. These data types are available in most programming language as built-in types, as I have told you. In C, we have different integer, float, character, pointers. In C++ also you are going to learn this, and in different programming language like Java, .NET, you also going to learn this. Next is non-primitive data structure. In non-primitive data structure are derived from primitive data structures. Non-primitive data structure emphasize on structuring group of homogeneous or heterogeneous data items. Now, you might have a question that what is a homogeneous data type, data items and heterogeneous data items. Homogeneous in normal word, homogeneous in English calls is like a group of a similar type of elements. So, in homogeneous data items, we have different type of groups in data items that have a similar type. In programming language, it calls as an array. In array, we stores homogeneous data items, like we can create an array of integer of 5 elements, or we can create an array of character of 10 or 20 elements. We can create array of float that have different points in it. So, that is a homogeneous. In heterogeneous data items, each and every data items are of a different type. Like one data item is of integer, other is on float, other we can combine and use that. So, in further we get divided into two categories: linear data structure and non-linear data structure. In linear data structure, elements are stored in linear fashion by means of logical or in sequential memory location. Elements are stored in a linear fashion, like a stack. Stack is a data structure in which insertion and deletion operation are performed at one end. As I have told you, when you are going to any kind of buffet or party, you have a stack of plates. You are going to take one and the next person will take another from same end. So, stack is a data structure in which insertion and deletion operation are performed at only one end. You are taking plates from front, you are not going to access from the lower bottom, and other person will also fetch it. If the waiter or some other person going to come with multiple plates, he will put the second plates into above your stack of your plates. So, we can say it stack is a data structure in which insertion and deletion operation perform at one end. Next is queue, a data structure which perform insertion at one end and deletion at another end. In queue, imagine yourself you are going to pay for your fees in your university or in your college. So at that point of time you are standing in a queue. When you going to the window of fee counter, you will end up by going out from other end. When another person come at the back of your queue, he will come one by one into the queue counter, and then they will going to transfer to going to and from different format. So that is a queue, a data structure which perform insertion and one end and deletion at another end. Now next is nonlinear data structure. Nonlinear data structure contain data item which are not arranged in a sequence. So when you are going to enter into tree, it will give you the different kind of tree type structure in which you have a parent node that will further divide into child node. That child node will also have different child node. So you are not going to arrange in a sequence format. So tree is a finite set of node in which data items are arranged in branch and sub branches according to the requirement. Next, our nonlinear data structure is a graph. Graph is a collection of nodes and connecting edges between node. Graph has similar kind of structure like tree, but in a graph we are having different edges and vertices. You are going to learn it in the further lectures also. That also use collection of nodes and edges between nodes to define a different kind of elements. Tree and graph are very well used in our computer network also to provide different paths and routing mechanism. So you can use this concept to develop your networking application or technologies also. Our next point is a time and space complexity of algorithm. Before going for time and space complexity of algorithm, let's just first understand what is an algorithm. An algorithm is a well-defined sequence of steps to solve a particular problem. Efficiency or complexity of an algorithm is measured with the number of steps, time complexity or storage location, which is called a space complexity. When any of the person comes with you with their kind of application they wanted to develop, at that particular point of time you are going to give them some steps to generate that application. Or we can say if that person go to some another place also, that person will also give his solution for that. So for each and every kind of program, or we can say a problem in context of our computer language, there is a possibility that you can have multiple types of algorithm for it, and multiple type of algorithm provide different kind of functionality with different kind of ways. At that particular point of time you will face a concept like time complexity and space complexity. In time complexity we can say that it is a time required for executing particular program. When we are designing any kind of application or program for any of the use, at that particular time we must keep the things in our mind that we must take less amount of time while executing particular program. It must take less amount of time for execution of program. Time can mean the number of memory access performed, number of comparison between integers, number of time some inner loop is executed, and unit that related to amount of real time the algorithm will take to execute. When you are designing any kind of program, when we write something like defining our variables integer a or b, and we are using that variables into different kind of our functionality, at that point of time where if we define that integer a and b again in our program, at that particular point of time while we are executing our program, it will take more time because we are redefining particular element again and again. So while we are creating any kind of program, we must see, or we can take care that if we use any kind of functions, loop, variable or memory access unit, we must use our existing system and try to compress that particular execution of time, so that our program will run more speed in a more speedy way. Next is our space complexity. The total amount of computer memory required as a function of input size is known as space complexity. When we are doing any kind of programming, at that particular point of time, we might just think of that our program must execute very speedily, right? In some lack of mind or in some other way, sometimes we are forgetting about the space complexity, the amount of space that we have to use at the time of execution of our program, right? So if we define multiple function for similar kind of functionality, and if we use different kind of methods to show our different elements, at that point of time, that not just take extra time, but it also takes extra memory space also, because each and every function have different kind of storage. When we are defining like a print show function to print some our data, and if we have another function like display to print similar kind of data, at that point of time, the function which have a show and the function which have a display, both will take a different amount of space and time for execution. So at that point of time, if we want to access our data and use lower amount of space to store that data, so we must use that concept of data structure and must reduce the time and space complexity. This memory requirement can be of direct requirements, such as memory required to store variable and arrays, or indirect requirements such as memory required for backend process like managing stack for recursion process. For example, in our program we have a concept like recursion. When we want to access our function multiple point of time, at that time recursion process also require some memory in our program. Each and every time when we have a recursion process, that recursion will store different will be stored into a different area of our program. So to reduce our space complexity, we must use we must try to reduce the concept of multiple use of function multiple function for each and every type of data. This is all for today's lecture. Let's just quickly mug up what we have learned from this lecture. First, we have understand about data, information and knowledge. So data is nothing but a raw piece of part. When data is processed as per the requirement, that is called as an information, and that information is organized into particular manner, that is called an knowledge. Next, we have shown what is a data structure. So data structure is a way of storing and retrieving data into computer memory effectively. Next, we have seen classification of data structure, in which we have primitive and non-primitive data structure. Primitive data structure is directly understandable by machine language, so this is called a primitive. Non-primitive data structures are derived from primitive data structures, right? Primitive data structure, we have integer, float, character and pointer. Each and every this data type are different for each and every kind of machine. Like in non-primitive data structure, we have array, list and file. Array stores similar kind of element. In list, we have two types, linear and non-linear. In linear data structure, we have stack and queue, in which each and every data is stored in a linear format, right? In non-linear data structure, we have graph and tree. The nodes we have generated, and that will also define for graph and tree. Then we have a file. that used to store different kind of element. Next, we have seen about the algorithm. An algorithm is a well-defined sequence of steps to solve a particular problem, and we have seen what is time complexity and what is space complexity. Time complexity is time required for execution of program, and space complexity is the total amount of computer memory required as a function of input size is known as a space complexity, right? In our next lecture, we are going to learn about how to find out and calculate the space complexity for particular subject, and we will see about different kinds of array, how we can use that particular array in our data structure. That's it from my side. Thank you very much. All the very best.
स्वाध्यायः परमः